Hello all, I hope that you all are doing well and you are finding this playlist course helpful so far. Till this point, we have covered the zero dimension tensor, which is called a scalar, and one dimension tensor, which is called a vector. From this lecture onwards, we are going to cover the topic of matrix, which is a two-dimension tensor. In this particular lecture, we are going to understand about the basics of a matrix, and we will also see on our Jupyter notebook that how to do basic operations with a matrix with the help of Python language. So let's get started. I have considered this matrix A for demo purpose, and as you can see, this matrix has 6 elements and it is arranged in 3 rows and 2 columns. As we can understand, the shape of this matrix is 3 by 2. If we talk about the indexing of this matrix, then it looks something like this. So if we consider this element, it is located at the second row and first column. Similarly, this element is located at third row and second column. This is how the indexing looks like in general. However, it is slightly different in Python because in Python the indexing starts from 0. This is why, as you can see, the row and column both are starting from point 0 over here. So this element is situated at row 1 and column 0. Similarly, this one is situated at row 2 and column 0. This concept of indexing in Python will be more clear to you once we go ahead and do the practical in our Jupyter notebook. Now let's talk about the transpose of a matrix. As we have seen in the previous lecture of vector, that every time we were taking the transpose of a vector, the row vector would become a column vector. Similarly, if you want to take the transpose for this particular matrix right here, then each and every row of this matrix will become a column in the transpose of the matrix, and this is why the alignment of the elements will be changed accordingly. So as you can see, 20 and 9 were the elements which were initially there in the first row of the original matrix. It becomes the column of the transpose matrix, and hence the shape of the transpose matrix becomes 2 into 3 because the transpose matrix has 2 rows and 3 columns. Therefore, the indexing of the transpose matrix will be changed something like this. So you can pause the video and have a look on this and it will make more sense to you. And this point is explaining how an element changes its position in a matrix after taking its transpose. Maybe in this notation it is not looking that much simplified, but if we want to take it like this, let's say that an element in the matrix A is situated at the location third row and first column. It will change its position to first row and third column after taking the transpose. So for example, in the original matrix, matrix A, we have 5 at the third row and first column. However, after taking the transpose, 5 changes its position to first row and third column, as you can see right here. Okay, that's pretty much all for the theory part. Now let's move into the Jupyter notebook, where we can do some practical operation on a matrix with the help of NumPy library in Python. So I'm going to import the NumPy library as np, and in the second cell I am creating a matrix in variable x, and we get this two-dimensional array right here. If we want to check the shape of this matrix, then we can use this syntax, and as we can see, we have 3 rows and 2 columns. Also, if you want to see the size or the number of elements within a given matrix, then you can do it like this using this syntax. Now let's go ahead and see that how to do slicing with a two-dimensional array in Python. So let's say that from this array x, I want to take only these elements in the second column. So I will have to consider all the rows like this, and only this column, which is the second column. Then how do we do that in Python? So we use this syntax right here. So I will give you a breakdown for this. So the first argument within the square bracket is a way of telling that how many rows you want. So this essentially means that I want all the rows from starting to the end. And the second argument is a way of telling that which column you want. And since we want the second column, this is why I am specifying 1, because the indexing starts from 0. And if I'll execute this, you can see I am getting exactly those elements that we wanted, 7, 16 and 9, which is there in the second column of the original matrix X. In the same way, let's say that from this same matrix X, I want to fetch only the second row, which is these values 15 and 16. So I need the information from the second row and both the columns. In that case, I will use this syntax. So as the first argument within the square bracket, as we know that we specify the row here, so I'm specifying 1 because as we know the indexing is starting from 0, and for columns I'm saying that give me everything from starting to end, which means I need both the columns. Again, if I'll execute this, I will get the desired output right here. You can also do a slicing by index. So in the first argument I am saying that for the rows give me starting from 0 and next 2 rows. For the column, again I am saying that from starting give me 2 columns. If I'll execute this, you can see I have 2 rows and 2 columns. So this is our original matrix that we have, and if we want to take the transpose, we can use this .t method to fetch the transpose of the original matrix. So if I'll execute this one, as you can see, all the rows of the original matrix becomes the column in the transpose matrix. Pretty much simple and straightforward. Now let's move ahead and see that how do we do some basic arithmetic operations with a two-dimensional array or matrix with the help of Python. So let's say I want to multiply 2 with our original matrix X. If I'll execute this, then it will do nothing, but it is multiplying 2 with all the elements in my original matrix. So as you can see, in the original matrix I had 20 and 7, that becomes 40 and 14, and so on. Each and every element is being multiplied with the scalar value 2. And equivalent to this multiplication operation, we can also do addition. Like if I execute the second one, then with each and every element we are adding the scalar value 2. And after adding this scalar value to our original matrix, you can see that it is becoming a new matrix altogether. So if you want to store this value to a new variable, you can use this one. As you can see, I am creating a new variable a, and the value will be output for this. We are adding 2 to the original matrix X. So if I'll execute this, it is the new matrix that we have achieved. And again, if we check our original matrix X, it looks like this. And we can add these two matrices as well. So matrix X and matrix A. So if I do it like this, we will get this output. And this addition operation is happening index wise. To simplify this element in the matrix X, which is there in the third row and first column, is getting added to this element in matrix A situated at the same position. And this thing is happening for all the elements of both the matrices, and this is how we get this final output. This is a way of calculating the Hadamard product by calculating the element wise product for each and every element within both the matrices. So if I execute this, it will make more sense. So all it is doing is it is multiplying 20 with 22, it is multiplying 7 with 9, and so on. By the way, this operation is called a Hadamard product, but this is not the way we do a matrix multiplication. Matrix multiplication is a completely different concept altogether, and just right after this lecture, we are going to have another tutorial specifically based on matrix multiplication, and the operation in that will be very similar to the dot product in vectors. So please do not consider this method as a matrix multiplication. This method is called a Hadamard product, or you can say element wise product. This syntax in the next cell is used in order to calculate the sum of all the elements in the given matrix. So 89 is the sum of all these elements in the original matrix X. However, let's say that you are not willing to add up all the elements within the two-dimensional array. However, you want to consider a row-wise sum. In that case, you can use this syntax by specifying the axis as 0. 0 refers to the row and value 1 refers to column. So let's keep it as 0 first, and if I calculate this, we will get 57 and 32. So it is pretty much straightforward to understand that how this calculation is happening. But just to give you a simple explanation, all it is doing is it is adding 20, 15 and 22, and we get 57. Then it is adding 7, 16 and 9, and hence we are getting 32. The final topic within this lecture is a Frobenius norm, and as we are already familiar with the concept of norm within this playlist, Frobenius norm is nothing but the way of calculating the magnitude, or you can say norm, for a given matrix. So it is denoted like this, almost the same way we denote an L2 norm, and all it is doing is it is taking the square of each and every element within a matrix, and then it is doing the summation for all the squared elements and finally calculating the square root of the value. We will go ahead and see that how do we calculate this with Python on our Jupyter Notebook. However, before moving on to that, few more things to remember, that Frobenius norm is very similar to the L2 norm that we have studied in the vector topic. The idea of a Frobenius norm is to measure the size of a matrix in terms of Euclidean distance, and it gives us the sum of the magnitude for all the vectors in the given matrix. So let's say that you have a matrix like this. Let's consider that you have a 3x2 matrix like this. Then each of these rows can be considered as a vector, and this is why it is saying that Frobenius norm can be considered as the sum of the magnitude of all the vectors in the given matrix. Now let's go ahead and see the implementation on Jupyter Notebook so that it makes more sense to us. So we are already familiar with our two-dimensional array X, and in order to calculate the Frobenius norm for this matrix, this calculation is happening behind the scene. So all we are doing is we are doing the square of each and every element, like we are squaring 20, then 7, then 15, and so on. We are squaring all the 6 elements, and then we are taking the sum of all the squared elements. So we are adding all the squared values, and after doing that, we are taking the square root of this final sum. If I'll simply execute this cell, then we will get this value. However, of course, you will not manually calculate the norm of a matrix or the Frobenius norm. So you can use this NumPy method in order to calculate the norm of any matrix. So I'm calculating it for matrix X, our two-dimensional array. If I'll execute this cell, then you can see that we are getting exactly the same output that we had over here in this manual calculation. Okay, so that is it for today's lecture. I hope that you got to understand the basic concept of a matrix. Going forward, we are going to learn about matrix multiplication and concepts like matrix inversion, eigenvectors and eigenvalues. So please stick to the playlist, and I recommend you watch all the tutorials in the sequence that we are uploading them, and it will help you to lay a strong foundation of mathematics as a prerequisite of machine learning. Thank you very much for your time. See you in the next lecture.